go.
Yeah, as Martin said, my name is Jason Ekstrand. A little bit about me. I am, and still am, a PhD student in mathematics at Iowa State University. And in late 2012, I started working on a little side project to keep myself sane. And the net result of that was to get involved in the Wayland project in the beginning of 2013. And I've been sort of hacking on it ever since. And then in June, I started at Intel and am working on the i965 GL driver. So that's a little bit about me. What we're going to talk about is full screen shells, which is a solution to a problem. And so in order to give a little bit of background, most people who've looked at the Wayland webpage have seen a picture that looks like this. This is a little bit different variant because I did it in blue. But this is basically what your classic X server looks like. You have the X server at the middle, and you have a bunch of clients that are connected to it. You have your window manager, which is another client that's also connected to it. And then you've got some device drivers, and you have some inputs and some outputs. And the exact details of those aren't particularly necessary for what I'm talking about, so that's why I left it kind of general. The Wayland model is a little bit different. So what do we do in the Wayland model? Basically, we just say, well, we want to run in a composited world where we're running GNOME shell or KWin or whatever. And the window manager is doing drawing, it's doing input redirection, it's doing all of these things. So let's just get rid of the X server. And now we have, in the middle of the picture is the compositor, the clients connect to the compositor, and the compositor talks to the hardware. And it uses OpenGL for compositing. It talks to KMS and DRM to do mode setting and buffer management. And it talks to EVDev devices through libinput and so forth. So the big question that comes up is, what about code reuse? Because obviously the X server does all sorts of things for us. And the classic answer to that has been push it into external libraries. So for mode setting, we use KMS instead of having all of the separate mode setting drivers. For buffer management, we use DRM. We use OpenGL or OpenGLES for compositing. If we want to do CPU compositing, we use Pixman. We have libinput for input handling. And as things are turning out recently, X is looking a whole lot more like this. We have Glamour, we have libinput-based input drivers, and a lot of that stuff is also getting pushed out of X, which is nice because we can share it between X and the Wayland compositors. So why not just use X? Well, X is a pretty decent compositor. It's efficient, it does a good job if you want to let it handle input and compositing, which most modern desktop environments, by modern I mean the composited ones like KDE and GNOME, they want to be able to, they're doing the compositing themselves, they're getting the client surfaces from X and then compositing them together and handing X back the buffer. And they want to be able to do input redirections so they can do all of their fancy effects and everything still works. And in this case, the X model doesn't work quite as well. So a couple of the major differences that are going to come to play into what I'm going into here, just a little bit more background. So the way the X operates is that it has one big common global namespace in which everything exists. You have Windows, Windows are within Windows, and you can set various properties on the Windows, and this is the way that everything talks. Any client can mess with any other client's Windows. They can get the size, they can reposition them, they can get the contents of another client's window, and so on and so forth. And this is how window managers are implemented. So your window manager is just a client, and it messes with the other client's windows in a very predefined fashion that we have set out in a spec so that nobody conflicts with each other, and it works pretty well. But it's just a client, and it's just messing around with other clients' windows, and that's the way the whole thing works. And then there's various other things like copy and paste that are handled by setting properties on the root window, and one client sets a property and the other client reads the property, and you pass things through that way. So everything is handled in terms of this global namespace. In the Wayland world, things are different. The compositor is at the center, and every client has its own namespace. Clients are completely unaware of any other client's existence As far as they're concerned, they're the only thing in the universe. And client's surface contents are completely kept between the compositor and the client. No client can read any other client's surfaces. This has some very nice security benefits. So for instance, if my client's surface happens to contain my bank account number and social security number because I'm doing my taxes or whatever, no other client can come and screen capture and read that and then send it off to the internet because it doesn't know that that other client exists. So there's all sorts of wonderful security advantages to this, but it comes with some downsides, as we'll see. So one of the things that X provides that Wayland doesn't is a common user space input-output layer. The word user space there is italicized because that's going to be important here in a minute. Basically, all you have to do, in quotes, is implement a DDX and everything runs on it. At least that's the theory. Okay. Whereas in the Wayland world, we use DRM, KMS, and OpenGL. And these are focused on getting images to hardware. But not everything is hardware. So the current abstractions we have in the Wayland protocol are mostly focused on getting your thing onto some physical screen. And not everything fits into that. So a couple of case studies as to where things start to not fit. One is what happens if we want to have a VNC or RDP session. So we want to have some sort of a remote management of our system. So in X, there's a couple of ways this is done. In X, the way you classically do this is you write either, hopefully you don't write a full X server. You write a DDX for X.Org, and that implements display over VNC or RDP and gets input over the protocol and talks to the clients just via X. And this can live entirely in user space. Doesn't require root to start it up because you're not opening any EV devs, you're not opening any display devices. And they just talk to it, clients talk to it like any other X server. So you can run your window manager, you can run your clients, everything's fine. You probably aren't going to run a full compositing manager because you don't have acceleration, but other than that, it's basically the same. A lot of projects have done this. FreeRDP, X11 VNC have both done it, and there's a number of other implementations that have done this. This poses some problems for Wayland. As I said earlier, current input-output abstractions assume hardware, and not everything is hardware. If you want KMS, KMS stands for kernel mode setting. You need a kernel driver. So if you don't want to have to install a kernel driver and you don't want to have to run as root, this is a bit of a problem. And we have external libraries. FreeRDP has is a library. There are VNC libraries. But this requires every library, every compositor to implement every protocol through the library. And you have a combinatorial explosion of VNC implementations, which is also bad. In Weston, which is the reference Wayland compositor, we have an RDP backend. And it works pretty well. But again, this is a single backend for a single compositor, which is not a long-term solution. So there's case study number one. We want to be able to do VNC and RDP. Case study number two, screen recording and sharing. So by recording, I mean you have some application, say VNC, and you want to record what you're doing because you want to make a demo of something or you want to record your game or whatever. And by sharing, I'm referring to more of a interactive thing. So you have somebody else who you're working with across the internet and you want to be able to share your screen with them. There's a variety of applications that attempt to implement this. Mac allows you to do screen sharing through their iChat. There's I think Microsoft has their own thing. There's Cisco has WebEx, and you can do screen sharing on that. There's a bunch of other different people who've attempted to do this. So how do you do this on X? Well, you can implement it as a regular client. And because a client can just go ahead and grab the entire front buffer, you just go ahead and grab the entire front buffer, encode it into your protocol, send it across the network, and probably do some diffing so that you don't send the entire thing. And you can fake input, and as long as the client, well, there are ways you can detect faked input, and as long as the clients are listening to the faked input, you can go ahead and move the cursor around and click on buttons, and everything works. Again, the fact that we can do this raises security problems. Clients can grab sensitive information from other clients. Clients can fake input and control other clients. There is nothing whatsoever that is special about this screen sharing client other than the fact that it does what it does. There's nothing preventing some other client from running the cursor around and clicking on things. Well, I shouldn't say nothing. There's tricks that window managers play to prevent clients from doing this, but nothing inherently in the X protocol. So what about Wayland? Well, as I said, clients are isolated. So no client can just grab the front buffer, and it can't just grab another client's window. It's completely unaware of anything outside of its own surfaces. Classically, so what that means is that any sort of screen capturing that happens has to happen and be done by the compositor. And what do you do with it? Well, you can pass it off to a trusted client, or you can deal with it directly in the compositor. The way we do this in Weston is that we do screen capture via doing just a GL read pixels off of the front buffer, and then we pass it off to some sort of a trusted client that we have installed someplace in a known location, and this is a known executable that's not going to go do something funny. So we have a screen shooter, which is a very, very simple client that just takes the image and saves it to a PNG file. And we have another one that saves it to a Weston-specific video format that we can then transcode. And we also have one that does direct to H.264 via libva. That was implemented a little bit ago. But again, this solution is Weston-specific and format-specific. So Weston has implemented stuff to do H.264 screen capture. Great. Now I want to do it in GNOME. We have a problem. So we need some sort of a mechanism for doing these things in a more general way. A few months, about a year ago, a little over, a guy came on who's Andrew Wedgbury, who's working at Real VNC, showed up at the mailing list and was trying to solve this problem. And the initial suggestion was, let's make a protocol for trusted clients to do screen sharing. Okay, well, it's trusted clients, so we have this chain of trust. That's all well and good. And it allows this trusted client to capture the screen and provide input. And the idea was the compositors implement one protocol. Many people write screen recording and sharing clients, and everybody's happy. That's the theory. The problem is that this turns out to be a lot of protocol. Basically, it's all of the protocol, only in the other direction. So where the Wayland protocol has things like input devices, we now have everything you would have for input devices only going from the client to the server. And everything that we had for output devices, you now have going from the server to the client. This turns out to be a lot of protocol, a lot more protocol than we really want to implement all over again. Especially because every time we update one of these things for the regular protocol, we would probably have to do exactly the same change in the other direction to the screen sharing protocol. So not an optimal solution. So the suggestion that I had was, why don't we just use what we already have? We already have a protocol that is set up for passing surfaces and their contents, and for passing input along. Let's just use it, only use it forwards like we're doing before. So in this model, the VNC or RDP server implements a Wayland compositor. just like any other Wayland compositors. Only instead of the compositor launching a trusted client, it launches a trusted compositor, and it plays the part of the client. And so now it's sending its front buffer as a surface to this other compositor that sends it across the network, and then the other compositor gets input off the network and sends it as input to the primary compositor, which is acting as the client. The compositor is still in control because it is in charge of firing off this other application. And we can keep that line of trust with the trusted executables. And almost all the protocol is already written. We don't have to rewrite it. We don't have to update it. It's there. So in this model, we change from our original picture to something that looks like this. So in a screen sharing setting, you have your compositor, you have clients connected to it, and it's still pulling in from lib input. It's still drawing out to the screen. But then it's also getting input from the RDP compositor that's sitting on top of and sending output to the RDP compositor that it's sitting on top of. And yeah. So to do this, I created something called the full-screen shell. So the full-screen shell actually covers a bit broader category of things than just screen sharing. That's the particular setting that I decided to present. But the basic idea is two very simple requests. One request is present surface. You give it a surface, you say, put this on this output. And it puts it on that output. And you can give it a scaling mode if you want it to be something other than centered. So you give it a surface, you just say, put the surface on this output. Stupid simple. The other is a little bit more complicated. Present surface for mode, where you say, put the surface on this output and use the surface size for your output mode, use this refresh rate, and it gives you control over at least some rudimentary mode setting. And so between these two, once we have a surface on an output, then we can just use the rest of the Wayland protocol to talk to the surface, and everything is just as per normal. OK, and now for the non-existent demo. I was going to have a demo, except I can't get XFreeRDP to not hard lock when I try to start it up. It was working on my laptop, but this is not my laptop, so I can't actually demo it. But so what we have implemented in Weston right now, which I was going to demo but can't, is a screen sharing plugin. So you start up Weston, you're doing your things, you press Control-Alt-S, and it fires off another copy of Weston with the RDP backend running that acts as our RDP compositor, and shares the screen to the RDP compositor. And then you can connect to it from the internet, and you now have your regular copy of Weston running over here, and you have your connection that simply mirrors the display. And this is also a great example of a multi-seat scenario, because the person who is on the other end, instead of fighting over a cursor, you each have your own cursor, you each have your own keyboard. You can interact completely separately. And obviously, compositors don't necessarily have to implement multi-seat, but if they do, that's a perfectly valid example of where one might use it. And it works pretty well as long as XFreeRDP is working. That seems to be the hang-up most of the time. OK, so as I said, this is set up for more than just one scenario. There's a lot of things that we can do with it. Screen recording and screen sharing is just the beginning. Other places we can use it is you can use it to be a little bit easier to write compositors. So some people do not want to manually deal with DOM and KMS. It's questionable as to whether or not it's worth not bothering, because it's not that many lines of code. But if you didn't, and you just wanted to talk the Wayland protocol, you could just make Weston deal with all of that stuff, and just run on top of Weston. We could use this to implement, for instance, user space mirrorcast. So David Herman did mirrorcast some time ago, and I believe that ended up involving a kernel driver. So in this scenario, you could have a Miracast app, and then your compositor just says, okay, I want to share this screen over Miracast. So it fires off the Miracast app, connects to it as a client, and starts displaying, and then it goes off to your television. So you could also theoretically use it to do some mode setting when kernel modules